All right, thanks a lot, Julia, and thanks a lot for the invitation. Very happy to be here, of course. I get this great opportunity to say a few things on the topics that I'm very much interested in, which is I had a long talk with Julia about what type of topic I should present. First of all, I came up, I thought, well, maybe I do a paper and then I can really go into detail and I can explain what is going on. But then we decided also to give a bit more of an overview of the field that I'm very much working on. So we'll present a few papers and guide you a bit through this particular topic that we are doing a lot of research on, which is basically my background is in regional economics. So I always look at regions. Those are close to my heart. And we have done quite a lot of research also as assignments from the European Commission to see to what extent European regions do well, economically speaking. And you have a big cohesion policy that actually has the main objective is to decrease income disparities across regions in Europe. This is already a policy field that is going on and active for many decades. I'm not so sure that a lot of progress has been made in that respect. But as a researcher, of course, it is very interesting and to explore why that is, why those disparities across regions remain quite stable over time. Of course, you have some dynamics now and then, but overall, okay, there's a lot to say on that. So we have been working on methods to see to what extent we can actually identify spaces of opportunities of regions, including low-income regions in Europe, to what extent they are able to move into new economic activities that can provide new jobs in their regions. And to what extent do they have opportunities, but also to what extent there are limits to what they can achieve in trying to come up with new economic activities. New economic activities are important, are crucial to develop because we all know that at some point of time, sectors, but also firms, they lose their dynamics. They might stagnate and decline and might even disappear from the market. And therefore, in order to secure long-term economic development, it is absolutely essential to come up and develop new economic activities to compensate for those processes of decline and stagnations that we can find in each of our regions. So this is really about the opportunity space of regions. So the story I will tell that it is very important to look at what type of capabilities are present in the regions because they provide those opportunities. But you really have to be very specific what you mean by capabilities and how you measure that empirically. But also to what extent regions can connect to other regions in order to access knowledge that might be actually very useful and helpful to move into new economic activities. And in the end, that is what Europe is about, right? It's about exploring complementarities across European regions, and those need to be activated in order to secure long-term development of European regions, wherever they are located in the European Union. So this will be a bit the topic of my talk. Most of the work that I will present is joint work with a fine friend and colleague of mine, Pierre-Alex Balland, who's also at Utrecht University, where I'm located, and he's also affiliated to the University of Toulouse. Okay. As I said, it's very important to look at and to explore where are opportunities for new investments in regions. And the type of approach that we take is a capability approach. So we look at to what type of capabilities are present in a region, and history matters. So it means that every region has developed different capabilities over time. It's a long-term economic process. Some regions get specialized in some activities and technologies. Other regions are very excel in other type of activities. So it means that the capabilities that are very strongly attached to those particular activities are very different from region to region. Yes. So the capabilities are important. So what is actually meant by capabilities? Well, it is the type of knowledge, the type of skills, the type of institutions that are available that condition which new economic activities will actually be feasible to develop in a region. So they provide opportunity, but they set also limits what can be achieved in this diversification process. So you cannot just diversify into anything. So all regions might want to become the new Silicon Valley, or they'll want to go for artificial intelligence, or they'll want to participate in the green transitions, but not all regions have the capabilities to do so. And we have to be very accurate on what we actually mean. We have what type of capabilities are needed. So this is, let's say, the main point of departure.
You need to share the slides, please. Sorry. The slides are not shared.
What is one of the main outcomes of studies that we did, and we did quite a few, is well, to this talk I can't remember. The more related a new activity is to existing activities in the region, to lower the cost of developing this new activity in the region. So if you already have relevant capabilities to move into artificial intelligence, you are more likely to develop that type of activity in the near future. And this is also has been referred to as the principle of relatedness that has been tested in many papers using all kinds of different data sets, using different type of methodologies, looking at different spatial scales, different at all parts in the world. And it seems that this principle of relatedness tends to hold and can explain to a large extent what type of new activities are actually being developed in a region and which specializations regions will develop. It's not working anymore. Always dangerous too.
Yeah.
Yes. Okay. Good. Okay. What is normally just to explain a bit about the methods? Okay. Do you see a difference? Okay. I'll look here.
Yeah.
So first of all, as I said, the probability to move into a new activity is very much related to the existing activities that are present in it. So how do we deal with that empirically? First of all, you have to measure the degree of relatedness between activities. What can actually one activity mean to another activity? Can it mean something in terms of shared capabilities or not? So that is the main principle. So when you, for example, when you look at technologies, but you might also look at jobs, you might also look at industries, you might also look at scientific fields. You can adopt this type of methodology on all those different type of activities. And here I just look at technologies, and you want to measure what's the degree of relatedness between technologies. You might do co-occurrence analysis. So you take patent documents, and you look at the patent document, and on the patent document, different technologies, different technology classes are mentioned on the patent document. And so you can look at hundreds, thousands of millions of patent documents, and you're going to see to what extent two technologies co-occur on a patent document at a high frequency. If they do, it's not a coincidence. They must share similar capabilities. If two technologies are never mentioned on a patent document, they might have nothing in common when looking at millions of patent documents. So then you define them as being unrelated. And that is how this principle, this technique works. And then you can really build a nice network in which each node, this is just a study that we did in the US with the US Patent Office data. And there we looked at each node stands for a technology. If there is a link between two technologies, it means that they're related above a certain threshold. So apparently those two technologies are often mentioned on a patent document, but those two technologies not, because there's no link, so they don't reach the threshold that we use in this particular network. And so you can actually see that you get a network in which some technologies are very much related to each other. They share similar capabilities, while other technologies do not. You have also different types of clusters, right? You can talk for hours on that, right? So you might even say, so here we have the USPTO classification, right? So they assign technologies to those broad categories. And if their categories would work well, the same technologies in the same color should cluster, right? Because what they have in common is, for example, capabilities in mechanics or capabilities in chemicals. So all the yellow dots should be somewhere in a cluster in this particular network. Actually, it's over there, but you see also that some of the chemical technologies are elsewhere in this technology space. So it means that maybe the classification should be updated because here we just let the data speak. We don't predefine categories, and we don't say already from the beginning what is a chemical technology and what is not. Now here we let the data speak, and we just see to what extent actually the ones that are being defined as chemical technologies are actually related to each other and should end up in a cluster. Also for mechanical, that this is a problematic category apparently because you see the red dots everywhere. Right? So this is already a nice outcome. You can talk with the USPTO and have a discussion about whether they should update because technological change happens all the time. And then of course, this network will also change over time. If you take a long-term perspective, the nice thing about patent data is that you can go back 2 centuries. And so we have a data set from 1795 till now, which includes all patents that were ever issued at the USPTO. Okay, so we have a nice measure of relatedness between activities, in this case between technologies, but it's still aspatial. So now we have to make it spatial in order to see to what extent regions have opportunities to move into new technologies, and this depends on technologies that are related to that particular technology. So then you calculate relatedness density. Last try, no, it doesn't work. So we use the relatedness density measure, which is a very simple measure in which you say, okay, how close or how related an activity J is from the current set of activities J in region C, in which that region is specialized, right? So you have a maximum value of 1 if it's 1 when that region C has a comparative advantage in all activities J that are related to the 1, to the I that you want to develop. And it has a minimum value of 0 when that particular region has no technologies that are related to that technology I that you want to develop. Very simple. So the higher the relatedness density, the more related technologies are available on which a region can build in order to move into a new technology I, right? Just ask questions when you want. Okay, so now we use this relatedness indicator, this relatedness density indicator, to see to what are the potentials of regions to move into new technologies in general, right? So we do it for all technologies. So here we measure the average relatedness density for all technologies, and we, in a way, we can distinguish between 250,000 technologies. But here, just to make it more feasible, I think here we distinguish between about 600 technologies, and we just measure the average relatedness density. So, what is the potential of regions to move into new technologies on average? And some regions score low, some regions score high. For example, Northern Italy, that was a surprise. Scores very high on this indicator, but it's a potential, right? Their institutions might be bad, so they cannot really activate the potential that they have. And there are other regions that do very poorly. They have very few opportunities to move into any new technology because they have no related technologies that might help them to move into a new technology. So you can actually see there's huge differences across regions in Europe. But this is for technologies in general. Well, you can be a bit more specific. this is a paper we did with Julia and others for the Bettelman Stiftung, and also here DG Regio was involved there. They now talk about the digital transition and the twin transition. And so they wanted to see to what extent which regions have the highest potential to move into, in this case, digital technologies. So we made a list of which digital technologies can you identify, and then we calculated the relatedness density of all those digital technologies. We summed them up, and then some regions apparently have a higher potential to move into digital technologies, to contribute and to participate in a digital transition than other regions, right? And this can already be very helpful in order to see to where you could focus investments, because the regions that have the highest potential might be most successful in that respect. Well, maybe you should not go into this region and develop digital technologies because they have no capabilities whatsoever. And that would be just a waste of money and a waste of public money and a waste of time. So it has huge policy consequences at the same time. You can go for green technologies, right? So here we talk only about green technologies. So the green transition is much more about technologies, of course, but if you about green technologies, so solar energy, we even included nuclear energy. Of course, you can have long debates whether nuclear energy is a green technology. Some say it is, some say it is not. So we should not include that. But of course, you can include it, exclude it from the data set. And you just calculate those average relatedness density towards all green technologies that we identified. In this case, I think we had about 24. You know better than I do. And here you see that some regions have much better capabilities to participate in new green technologies and can contribute to that than other regions. So again, huge differences across regions in Europe. There's unequal opportunities everywhere. And policies should account for that. And so when they try to develop these type of new developments. But you can also go more detailed in a way. You can go to all the 250,000 technologies and make maps, right? So here, if they're interested in hydrogen technology, here's the opportunity space of hydrogen technologies. Where's the relatedness density highest towards hydrogen technology? So what capabilities do you need to move into hydrogen technology? And can you exploit and explore? And some regions have much better opportunities to do so than other regions. So here again, this region I would not bet my money on going for hydrogen. Well, many regions in Europe really would like to go into hydrogen because they want to participate in the green transition, and hydrogen is considered to be one of the key technologies. And then they develop plans and they develop strategies, and they want to go into hydrogen technologies. And if I look at all those strategies and I map it, I put it on this map, you might actually see that some regions actually do well. They really go for the right technologies because they have strong capabilities to move into that. But there are also cases of regions that have big plans on hydrogen technologies and they have no capabilities whatsoever. So they're doomed to fail and to be successful in developing that. So that's one thing. So that was the principle of relatedness. So you can already define opportunity space. Also, we have linked very much this to the whole economic complexity literature introduced by Hidalgo and Hausmann. I've seen already some paper presentations, and I saw also in the program that there will be other papers on that. So so people like it probably, although there's a lot of debate about what is complexity and how it should be measured. That's even that debate is going on. Let's put it like that. But just go back to the idea, what is complexity? So it's not only about going into new activities in which you have strong capabilities, but it's also a matter of upgrading your economy to go into the more complex activities because those are more difficult to copy and to imitate. So if you succeed to move into a complex activity, you might get higher economic returns. And indeed, we just did a paper. I wanted to present that paper here, but in which we did a study, was published in Regional Studies last year, in which we could actually show that the regions that were capable of moving into more complex activity, they had highest GDP growth, but especially more employment growth. So it matters economically speaking. So it makes sense to go for more complex activities. Activities are considered complex, as I said. Well, you can talk for hours on how this be measured. We follow the original approach in the method of reflection that takes into account two characteristics. Activities are considered complex when they are unique in the sense that not many regions are capable of producing that activities. So if you find only one or two regions that are really heavily specialized in one particular technology, like artificial intelligence, it might indicate that it's a very complex technology and very hard to copy or imitate. And the second element is the diversity element, in which a complex activity is considered complex when you rely on a wide range of different capabilities, and you have to combine them. You have to coordinate that, and so it's a complex technology for that reason. Artificial is very complex because you have to combine very different capabilities, and not many regions, not many organizations are actually mastering that. So that is the idea about complexity. So you not only want to not want to diversify into related activities, but you also want to make your economy more complex. If you have that idea, you can make a nice matrix on dimensions. You can plot all economic activities, whether they're technologies, whether they're jobs, whether they're industries, doesn't matter. You can use all kinds of all those type of data. And they score low in a region, they score low or high on relatedness. So if you have low, you have no capabilities whatsoever in that particular activity. And when you score high, you have relevant capabilities to move into that. And you score low, and those activities have low complexity or high complexity. Now, every region in Europe and elsewhere, they all want to go for the right-up product, right? So you want to develop new economic activities in which you have relevant capabilities, and that would make your economy more complex. So that's why we call it low risk, because you can build on existing capabilities. You do not have to start from scratch. So the costs are much lower to develop that. And it will bring higher economic benefits because you're one of the few that can actually compete and excel in that particular activity. So low risk, high benefits. Everybody would go for that. An interesting category, an interesting quadrant is this one, right? So that you don't really have so much relevant capabilities. But if you succeed to develop that new economic activities, you can reap high economic benefits. But it's a very risky strategy because you don't have the relevant capabilities. So high risk, but if you succeed, high benefits. You might also have opportunities in this quadrant. You have relevant capabilities, but it will not add much complexity to your economy. So yeah, you will develop some new jobs, but those are not complex ones. So you're always sensitive to outside competition, and the returns, the economic returns might not be that high. So low risk, but low benefits. And this is, of course, the most stupid thing that policymakers can do, is that you take high risk and low benefits, you go for the very low complex activities in which you have no relevant capabilities. So that is probably, it's amazing sometimes actually policymakers doing that. Now, okay, this is, see, let's go to the data and see, and just show some examples. You can do this for all regions. As long as you have the data. Here I just took industry data, and here you have the relatedness density on the x-axis and the complexity on the y-axis. This is the region of Ile-de-France, Paris region, one of the richest regions in Europe. And why is it rich? Because of this positive relationship, right? It has the highest, it has the industries in which it excel. Positive relationship. So the higher relatedness and the more complex the industries, the more Ile-de-France is successful. So, okay, so I have to explain. The dot shows the relative comparative advantage, so it's a specialization measure, right? So first of all, you can actually see that the relatedness measure really works well, because the more you go to the right, the more relevant capabilities are present in Ile-de-France region, the more Ile-de-France region is specialized in those particular industries, right? You see the dots become bigger the more you move to the right. Well, here, Ile-de-France does not have any relevant capabilities. And therefore, the dots are very small because there is no supportive environment in the region, that there are no relevant capabilities to develop that. And that's why the region is not specialized in those particular activities. So the principle of relatedness really works well. And why would Ile-de-France care? Because those are low complex activities. So why would it make any effort to invest in that? Does not make sense. Well, why is Ile-de-France super rich? Because it is highly successful in the most complex activities with whom nobody can compete. This is Ile-de-France. So the Ile-de-France has an opportunity space which is just great. They have the biggest opportunities in the most complex activities. Now we go to Silesia region, an old coal mining, old steel region in Poland. And what we find in the data, and it's quite remarkable, for many old industrial regions, we find this negative relationship. So they have some potential, but in the least complex activities. So the capabilities that they have do not allow them to move in the most complex activities. You remember the right up quadrant, low risk, high benefits. There are no opportunities there for Silesia region. That is just the fate of the Silesia region because of its past. History matters. What type of capabilities are present in the regions? Again, they provide opportunities. But here, in this case, they set also limits to what you can achieve in this diversification process. So Silesia region is heavily constrained by moving in the most complex activities. Of course, Silesia region would love to go into the most complex one because it will bring the highest economic benefits, but it does not have the capabilities to do so. And this you see for many old industrial regions, negative relationship. Now we come to the peripheral region. I just took Extremadura. I always take this, and then people in the region of Extremadura always saying, can you not take another example? First of all, you can actually see that the maximum score relatedness density is 100. Right? You can actually say that Extremadura region has no capabilities whatsoever to move into any industry because the relevant capabilities are really poor. That's why Extremadura region is one of the poorest regions in Europe. It does not have opportunities to move into activities, let alone the more complex ones. And therefore, it has a hard time. And that's why it's peripheral, and that's why it's a low-income region. Okay, so this is another. This is the Betterman Stiftung project, right? That we did. So you can make this type of maps, right? So graphs all the time, again, related to complexity. Here, this was a project on the twin transition, so the green technologies and the digital technologies. First of all, you can actually see that digital technologies are more complex than the green technologies, right? So this is also what you expect, right? So the most complex green technology is battery technology and electrical vehicles and solar energy. But of course, big data or Internet of Things is much more complex. But here I just mapped, we mapped it for all the high income regions, right? The regions that have a GDP higher than above the European average. And And again, a nice positive relationship. Right? So you have the highest potential in the most complex technologies. So high income regions have much more opportunities to move into to contribute to the twin transition than other regions. Different picture for the low income regions, negative relationship between the two. And so they have the highest potential in the least complex twin transition technologies. But what we found very interesting is that those low-income regions have quite high potential in green technologies. So you could actually say they have relevant capabilities to move and to participate in the green transition. So let's focus on that. There are opportunities for even the lowest income regions, because the capabilities that you need do not need to be very complex. So they offer opportunities to move into that. And of course, you can distinguish that might be true for biofertilizers or sustainable packing, but they should not go in battery technology because they have no relevant capabilities. Right? So you also have to be specific about which technologies you're talking about. Well, then about cohesion policy, right? So so if we now take all that material together and we look at those different opportunity spaces that exist across regions in Europe, and how do high-income regions and low-income regions score on that? We just, in a publication published last year, we did it both for technologies and for industries. And here we looked at the correlation between the relatedness density and complexity of potential entries. So potential entries are technologies or industries in which the region is not yet specialized, right? You really want, where are the opportunities to move into new specializations, in new technologies or new industries? Where is that? And if you have opportunities, are those in the most complex ones? Yes, if there is a positive correlation between the two. So in red, you have high relatedness in the most complex technologies. And some regions are very lucky to be in that. Well, if there's a negative correlation between the two, it means that, yes, regions have opportunities, but in the least complex activities, in the least complex technologies. So we mapped that just for technologies, and we did it for industries. And what you can already figure out a bit when you look at this, although this provides a lot of details in those type of maps, is that high income region, no surprise, they have the highest, the best capabilities in the most complex technologies and in the most complex industries. While low income regions, they have the highest opportunities in the least complex technologies and the least complex industries. Well, you can also what we did here is the average complexity on the y-axis of this is actual new entries, right? So this is for, okay, those two panels are for technologies, those two panels are for industries. Here on the x-axis is GDP per capita. So we divided all the regions in three group of regions of equal size. So low, medium, and high GDP per capita. And we look at the average complexity of new entries, right? So, and you can actually see that the higher the GDP per capita, the higher the average complexity of new entries, and that is what you expect, right? So, and this is, of course, has consequences for of the fortune in the near future. Yes, and the same for also made a distinction between the old member states and the new member states. And actually, you can see that the old member states have much more opportunities to move into the more complex activities than the new member states. So this has consequences for regional inequality, to what extent cohesion policy can make an impact here. And we should account for that because in that sense, the future might not look too bright because high income regions have much more opportunities to move into new activities. Okay, so far I talked about the capabilities that are present in the region. I just kind of assumed that all regions are isolated entities. They do not trade, they don't exchange knowledge, there's no labor mobility whatsoever, or at least I did not account for that. So also what we are now doing, and this is more recent literature, in which we try to see, is it possible that if you lack some capabilities to move into something new, that you can get access to those capabilities that you need by connecting to other regions, right? And indeed, we have a paper on that, which we actually show that regional diversification and there it's not just by linking to any region per se, just to be exposed to the outside world. That is what often regional economies tend to say, is that okay, you do not only rely on what you have in the region, but you should also connect to the outside to get access to external information, etc. And that might be good. But it really depends to whom you are linking, because you need to have the absorptive capacity to understand the external knowledge that is available elsewhere, and to absorb that and to use and exploit that in your own region in order to move into a new economic activity. Right? So, and this is what we could actually prove, is that regional diversification depends not on external linkages per se, but those that provide access to capabilities in other regions that are lacking in the region, but they are related to existing capabilities in the region. So, yes. So how do we do that? So here we have again the relatedness complexity matrix, right? So let's take an example. You have one region A. This is technology I, artificial intelligence. And let's say that region has already 50% of all the relevant capabilities that are needed to move into artificial intelligence. And now it can think about, okay, to which region should I connect in order to get access to those relevant capabilities that I need, but that are missing in the region. So in that sense, it would make sense to connect to region B, because you would add 30% to the 50% of relatedness density that you already have. So you better connect to that region. So it's not just by connecting to any other region. Now you have to be very specific. Where are complementary capabilities? Where can I exploit complementarities in order to innovate and to move into new economic activities? Well, you can connect to region C, it will add 20%. And so, of course, you can do that for all regions and do the calculus. And for example, you can make maps again. And you can make 10,000 of maps of those, right? So here it's for Ile-de-France region. Just a random example. So this is Ile-de-France region wants to go into hydrogen technology. It might have some capabilities itself to move into that, but there are some capabilities that are missing in the Ile-de-France region. So it might now have to look for capabilities elsewhere. And by using this complementarity indicator that I explained before, how much related density can be added to the relatedness density in terms of hydrogen technology to the Ile-de-France region. This is the map, right? So for example, in this case, there are a lot of French regions that could mean to Ile-de-France region to connect and to exploit complementarities that are available in France. So Macron is very happy. Right? He say, well, I don't have to work with all these other Europeans. I just make my own national program, because all the capabilities are present in the region, are present in France, not in the same region, but I can stimulate collaborations between those that can be identified using this type of map. Well, as I said, you can do this for all 280 regions, and you can do it for all technologies. So you get how many maps? I don't know, but many 10,000s of maps. Now, the dreadful case of Europe. Because now we have complementarities maps, right? So ideally speaking, Ile-de-France should have connected to those regions that might matter most to them in order to move, in this case, to a new hydrogen technology. The tragedy of Europe is that we don't make those connections at all. We don't exploit complementarities, which is very much against the European idea, because it's about exploiting what can other regions mean in Europe to each other in order to reach a higher level of economic activity. So here, I don't know, we took always this example of Arnsberg. I have no idea why we do that. That is just an example. This is again a complementarity maps that I explained before, right? This is for hydrogen. Okay. So Arnsberg, if it wants to develop hydrogen, and of course it does not have all relevant capabilities in-house, well, it better should connect to this one or Norway. There's expertise there that they could tap into in order to move this forward. And now, with the data that we have, and here we use patent data, we use technologies, and the linkages that we look at is co-inventor linkages. So you have patents in this case on hydrogen technology, and you look at how many inventors collaborated on that patent document. If the two are in different regions, there's an interregional collaboration. Okay? So, co-inventor linkages. So what we actually see in this case of Arnsberg is actually this, I think it's the 10 most important linkages, I think, that we did here, is you can actually see that most of the linkages that they have are within Germany. And you might look at this map. Do those regions really show the highest complementarities for Arnsberg in this particular case? And they have some international linkages. Okay, so you can do this for every region and for every technologies, but just to get the idea. Now, we're going to use this information to see, okay, so we have complementarities. So that would be the ideal picture, right? So we should connect to the right ones that can provide access to the best complementarities. And then we will be much more successful in Europe to develop new economic activities. But what our analysis showed in the study that we did together is that there is enormous untapped potential in interregional linkages. So meaning that we estimated an ideal AU network predicted by a gravity model in which we also accounted for real-world constraints, geographical proximity, right? So spatial distance, of course, the higher the spatial distance, the less likely you're going to collaborate. You take a mass variable, of course, gravity model. So you take the number of patenting in both regions and you sum them up. So you expect that regions that have a high patent activity is more likely to collaborate. You look at the cognitive profile. We did with relatedness density. And the more relatedness density are in two regions, the more likely to collaborate. And we had a same country variable, right? So our two regions located in the same regions, they're much more likely to collaborate. Guess what? In the gravity model, the same country effect has the highest predictive power, right? So all regions in Europe, they tend to collaborate with others within the same country. They don't exploit complementarities that might be across their border. And this is actually what we could show, and I just showed some descriptives here. So we mapped for each region 3 interregional linkages with the highest number of actual linkages, which you will see that has a high national bias. And we look at those regions they should connect to, but which they are not doing. So we take the three most important interregional linkages that have the highest untapped potential. So those are the ones that they connect to, but they have no complementarities whatsoever to offer to that region. I can show you the gravity model if you have questions about that, but just for the sake of time, there's 3 minutes left. This is, two maps of our digital technologies, right? So here on the left side map is the actual linkages, the 3 most important actual linkages that regions connect to other regions. The red ones are within the country. The yellow ones are cross borders, international relationship. And you can see that the red links are dominating. Right? So most of the 3 most important interregional linkages each region has to develop new digital technologies are within the same country. Well, our theoretical model, when we predict to whom they should connect, right? And these are the three most important interregional linkages with the highest untapped potential. So the ones that could provide the best complementarities they're not connecting to, they're all international. They're all international for digital technology. So it means that we are doing a wrong job in Europe. There's a lot of national bias in the interregional collaborations that we observe in reality. Well, in theory, following our model, they should exploit the complementarities that are available elsewhere, and they're not doing it in Europe. So there's a huge untapped potential. And this is what Europe is about. It's about connecting regions with other regions, even across national borders, in order to make Europe stronger and to compete with the US and with China. And this is not what is happening. Same story for green technologies, even worse for green technologies. There's even a larger national bias in our data. Well, again, theoretically speaking, where are the complementarities? You have to connect internationally to exploit and to mean something to develop new green technologies. Okay, I think I'm right on time. Yeah, okay, good. Thank you.
So we have 12 minutes for discussion. Yeah, are there any questions? Please.
Hi, thank you so much, Ron. I'm particularly interested in one of the last few months, the one on digital, the collaborations with the digital technologies you show. So one of the things you are telling us is about the collaboration and how we need to collaborate with others, the digital ones. But this kind of collaborations is to continue develop the same technology, right? So the example you put before, it was about hydrogen, for example. One of the things we know with digital technologies is the potential of these technologies to be complementary between themselves. So somehow maybe you don't want to collaborate with somebody else to continue developing AI. You want to collaborate with somebody else because you know that for AI you will need big data.
Yes.
Where this complementarity between technologies will appear in the story of complexity versus relatedness?
Okay, so probably I did not explain it too well. Sorry for that. It's not collaboration on AI. It is where are the related technologies that you can actually tap into in order to move into AI, right? So there are all kinds of capabilities that are present in the region, not necessarily in AI. Not even necessarily in digital technologies, might be also non-digital technologies. But as soon as they are related to AI, they're in my data. Right? Because what we also want to be, and there's a high correlation between AI and relatedness density around AI, right? Because that's what you expect is how the principle of relatedness works. But also there's an idea behind it because it might be the case that the ones that are excelling in AI don't want to collaborate with those that are excelling in AI because there's also a thing like competition, right? So you don't want to share knowledge with your competitors, right? So this is also captured in this indicator.
Same stuff. As you could guess, this is about econometrics. One thing that when I look at these maps and the story that you tell, the reason why Paris doesn't do hydrogen might be because they just don't have the capability.
Yeah, exactly.
And that explains why nobody wants to work with them on hydrogen. And so that also explains why they're not working with people who are good at hydrogen. So there is some kind of...
We estimated an econometric model to account for that, and we looked also in the interaction effect, right? So, and there is a complementarity. Right? So you need to have some capabilities. You cannot start from scratch and just connect to other regions because the logic of this indicator is you need absorptive capacity. If you have no capabilities whatsoever, in that you don't have absorptive capacity. Right? So, and this is also what we, I don't know if I have it in my, show the economic model. But there's an interaction effect, relatedness density and complementarity. and it's positive. So let's say the capabilities that you have are reinforced by connecting to the ones that provide complementary capabilities elsewhere. Because
You showed us these bar plots where you showed that regions with higher gross regional product tend to have more positive correlations. Yeah, this one. I was wondering, how would that look if you would split between rural and urban areas? How
Yes.
does it relate to urban rural?
we have that, but not in this slide. But it's in the article. I just took those two out. But indeed, there is, okay, as you can imagine, in cities, we took population density, for example. You see exactly the same thing. Low and high population density, average complexity of entries is much higher.
Yeah, I have a question regarding the maps in the back of the presentation. I thought you would move, but I thought you would move in the slide. That's fine. I have a question.
Slide you want?
The last map with the digital.
Last map.
Yeah. Yeah, perfect. Yeah. I was just wondering, what do you think why the actual collaborations do deviate so much from the optimal? So is it because maybe social interaction plays a much bigger role? I guess, yeah, path dependency is an issue, but yeah, what do you think? Why? What are the reasons?
Well, very relevant question. The easy answer is we didn't investigate it. But of course, we know this is not a new story, right? So that we tell because we know there is not much international collaboration going on across European countries. Reason why is because we have our national research systems, we have our national educational systems. You mentioned already social proximity might be a good driver of this. And of course, the more close you are geographically speaking, and you speak the same language, you belong to the same culture, you share the same norms and values, you're more likely to collaborate. And of course, then the country, in fact, will be big. So so we didn't investigate that, but that's probably what is.
Yeah, just a curiosity. Perhaps it's a point that I have not understood well. But the convenience that you're talking about in establishing a collaboration with complementary region, is that mutual or it can be only one way? I mean, so when you say we should favor establishing collaboration between, I don't know, Malta and I don't know what. So it's convenient for Malta, but I don't know if it's convenient for Bayern to establish at Malta.
Yes. Well, I mean, okay, so we did co-invent the linkages, so we don't see the direction of the flow. Okay. We could do pattern citation analysis, and then you see the direction of flow. But I already can predict that Malta wants to collaborate with Bayern, but Bayern is not interested.
That's the one, yeah, no, I mean, so well, the policy implications, so are more direct if you look at the mutual convenience at collaborating.
Exactly. Now we assume that inventors in both regions benefit from that collaboration, right? Because there's a patent.
Yeah.
But we cannot assess which contribution each inventor did.
Hi, thanks for the fascinating presentations. I have two remarks/questions. Both concern path dependence. So you impressively show how to optimize or potentially optimize regional collaboration in a tech space. That's all fair, good and fair. However, that's a status quo. So there's this potential, then there's a potential of developing new capacities altogether, thinking of the battery technologies, for instance. Then we would quickly be in the pretty problematic quadrant, actually, highly complex products with lots of competition, especially from China. So do you have any idea of how that would fit into this framework? Sorry. And the second question, just briefly, 7 or 8 years ago, we did a similar study using similar methodologies for the European Commission. And what we were looking into is not only relatedness, but also unrelatedness. And what we found that in the short run, relatedness path dependence was growth conducive. In the long run, it's the unrelatedness. Could you say anything about if you want the tipping point where these two switch? Thanks.
Yes. Well, start with last one. This is unrelated, right? This is unrelated diversification, right? This you don't have relevant capabilities, but you're still able to move into something new. It happens. It happens now and then. It's very rare. We had a paper with Cesare Hidalgo published in Research Policy, in which we really went into this. What are the drivers of unrelated diversification? So you're absolutely right. It's a very interesting topic by itself, right? All we are saying, we are not necessarily saying that if you have opportunities, you should always go for those. Now and then you might go for those, but it has policy implications because the type of policy you have to do here you have to build new relevant capabilities, means you have to create new research infrastructure, completely new institutions. So it's really, you really have to make an enormous effort to make that happen. Well, here, it's much more easy because you can build on relevant capabilities. You might adapt a bit your research system or your capabilities in education, but you don't have to transform it completely, right? So that's a fair point what you said. The first one, yes, there is dynamics, of course, going on in relatedness, right? So it's not, I mean, we are living in a world that is full of dynamics. So the technology space that I showed 10 years ago is very different from the technology space. I could have shown that in a number of slides. For example, it's very, Detroit was at the technological frontier in the 1930s in the US, right? The whole technology space was focused on mechanics and patenting in mechanics, and Detroit was the absolute leader, was at the technological frontier of those days. And now if we look 80 years later, it's nowhere, right? So the patenting that you see in Detroit is completely fragmented. They patent a lot, but in very different activities, there's no cohesion anymore whatsoever. Silicon Valley in the 1930s did not exist. Was no patenting going, was a bit of patenting, but nothing in particular. Nowadays, of course, it dominates the technology space in the US. You see, so there's a lot of dynamics going on. So you have to take a long-term perspective. So if you take a very long-term perspective, yes, there are dynamics going on. And those dynamics can even go very gradually. You don't need to make jumps in order to make radical change. As long as your time horizon is big enough, you can still see dramatic changes in your spatial system.
In the last slide, you showed where you compare the two pictures from your model and the actual connections. Just from eyesight, one cannot distinguish whether the difference is due to factors that come from spatial proximity, potential advantages of clustering of innovation activities, and what is really due to the lack of a European Union innovation space.
Yes.
What is the measure of fragmentation versus the proximity? I assume maybe you've done the econometrics.
Yeah, we did some in other papers here. Okay, here I only want to say is that when measuring this complementarity matrix, we take into account real world constraints. So we had in the gravity model that I was talking about, we take into account the geographical proximity. So we don't say, well, that's not important. So that's included already in that one, right? Also, the cognitive profiles and the relatedness density, the mass variables that I was talking about, is in there. So we already account for that. But we only add the complementarity indicator and see how it changes. Right? So if you should go for complementarities, still accounting for real-world constraints like geographical distance. And still, so we take a very conservative model. Because I could also say, well, geographical distance does not exist, and just look at complementarities. And then you might say, yeah, but you should account for that because we all know that geographical distance is a variable. No, we take that into account. And still, those complementarities are elsewhere. Only funny enough for green technology in Italy, they seem to. There are some red lines there, so they can work together. Because they can really offer complementarities to each other. So who knows, Italy will be on the next green level in the next 10 years or so.
Last question. When you consider benefits, did you consider sort of within country inequality increasing?
Yeah, we have now a paper, but it's okay for interregional inequality. I already showed this is, but we are fighting this intra-regional inequality. We have now a paper, and it took us 3 years to go through the referee process, and we're still not there. The problem is my own, because I cannot really theorize well on this. How to theorize what would I expect? What would be the effect on intra-regional inequality? I was thinking, oh my God, what should I say? And I could not make it. I could not make it perfectly work. We have the data, and we get we make the claim. Well, we provide some empirical evidence that related diversity. So if you diversify into new activities that are related to the ones that you have, it will decrease intra-regional inequality. Now, your next question would be, what type of mechanisms? And here you go, right? So this is the issue that we are still very much struggling with. So till so far, it's very explorative. And just let's see what happens in the data, and can we learn something from that? But this is, it's a crucial topic, right? So because everybody's talking about it, if there is some inequality, it's fine, right? So there we have a good story to tell. But intra-regional inequality, because we know that the most complex cities in the world are the highest unequal ones. The cities that innovate most are the most unequal ones. So the two do not go together.
I thought it would increase.
Yeah. And this is okay. So the labor economists that say, okay, you have a segmented labor market, right? So in San Francisco, there are the very high educated and the very high income people, and the very low income people that serve the high income people, and that's why you have high inequality. So they cannot live in San Francisco, the low income, they have to come from far and have to commute long distances. So we go a bit into that direction.